Hello everyone, I am Abdullah Abu Alim and I'm going to present our paper about improving single image defocus deblurring and how dual pixel images help you through multitask learning framework. This work is done with Mahmoud Afifi and Michael Brown. And before I start, note that you can access the GitHub page for the code and dataset by scanning the QR code here. First, let me describe dual pixel or DP sensor. A DP sensor, which is common in smartphone cameras, provides two photodiodes at each pixel location as shown here. By creating images from the left and right photodiodes, we obtain two sub-aperture views at single image capture. These views exhibit a difference that is correlated to the amount of defocus blur. DP sensors are used for autofocus, but last year, myself and Michael demonstrated that DP data can provide useful cues for defocus deblurring in a data-driven approach. In our prior work, we used a data-driven approach based on DP training data to perform defocus deblurring. The work required paired data for training, namely two blurred left-right DB views and a corresponding single sharp image. DB data was also required at inference time. The challenge in this prior work was that collecting this paired training data was a tedious process that required a careful setup. Another challenge is that while many cameras use DB sensors, currently only two models provide access to the DB data. However, we still want to perform defocus deblur for cameras that do not provide access to DB data. So the questions we sought to answer are: can we reduce the reliance on paired and hard to collect data? And can we design a deblurring method that works on a single image input at inference time when the DB data is not accessible? To address this question, we propose our multitask network that has single encoder and multiple decoders. Our network is a single input model that takes the blurry image and estimates the two DB views and the corresponding sharp image in a multitask framework and through three decoder branches. The main idea of this proposed multitask framework is to first train for the DBView estimation task using the DB decoders and DB data. The nice thing about this type of training is that it doesn't require paired data or a careful capturing procedure, as all we need is unpaired DB data that can be captured in the wild with no constraints. For this first training stage, we were able to collect thousands of training images. In the second stage, we trained for the other task of defocus deblurring to estimate the sharper image through the deblurring decoder branch. In this second stage, we trained for the two tasks jointly. As for the inference time, our multitask network doesn't require the DB data to be available at inference time, which makes it able to deblur for a single input image. Not only that, it also estimates the DB views of the single image input. Training for the DB view estimation task is not trivial, as the network takes a single image and predicts two images. So using the typical L2 losses for the predicted outputs and the ground truth is not sufficient, as the network couldn't address the front-rear defocus ambiguity as shown here in the animated DB views. So if you look at the ground truth DB views, they exhibit the rotating difference around the focal plane, whereas the predicted ones are moving in the same direction for front and back focus. Another DB property that the network couldn't learn is the flipping of the DB blur kernel, or the circle of confusion COC. So if you look at the ground truth DB views, you can see that half circle COC is flipping between the views when you look at the light bouquet. On the other side, the predicted views exhibit implicit image shift, not half circle COC, as it can be clearly seen at the light bouquet here. See paper for details on the DB blur kernels. These observations led us to think of designing loss functions that can help the network learn basic DB properties. So based on our understanding on how dual pixel sensor work and the physical model behind, we propose the first DB loss that considers the fact of the input image is actually a combination of the DB left and right views. The other loss we introduced was to help the network capturing the half-circle COC shape and the front-back focus ambiguity. And by looking again at the DBCOC formation model here, you can see that if you take the difference of the COC at different scene points, you can get a sign difference that can reveal whether the point is front or back focus. Therefore, we introduce the second loss, which is the DB difference loss. After adding the dual pixel combination loss LC and training our multitask network with the other loss functions as well, we can see the video on the right. Our network is able to capture the front-rear defocus ambiguity as we alternate between the dual pixel views. If you look at the ground truth and the predicted dual pixel views, they both exhibit the rotating difference around the focal plane. Here, I show the effect on our multitask model after incorporating the difference loss LD. So the video on the right alternates the predicted dual pixel views and shows that our multitask model is able to learn the shape of the flipping half circle COC and is similar to what we see in the real dual pixel sensors. For the quantitative results, we compare with other single image defocus deblurring methods, and our method achieves the best results for all metrics, including the signal processing metrics and the perceptual metric Naturalness Image Quality Evaluator (NIQE). We also achieve on-par results with other methods that require dual pixel data to be available at inference time. Furthermore, our appellation study demonstrates that each task is useful to the other in our multitask framework. In particular, predicting the DBViews help the deblurring branch to get better results and vice versa. As I mentioned earlier, we train our multitask network using one defocus disparity direction, so the predicted views are always left-right dual pixel views. Then the question is, what will happen if we rotate the input image and feed it to the network? Let's see what will happen. We can get multiple sub-aperture views synthesized from each rotated input image, and by alternating the synthesized views, we can get this nice image motion effect or NIMAT effect. Here's some more result visualization of the NIMAT effect of data from Canon camera, and this nice effect is all generated from a single input image. All our training data is captured using a Canon camera, but still, our multitask model is able to generalize for other cameras and generate the NIMAT effect for an image captured by a Nikon camera. To summarize, we introduced a multitask framework for dual pixel view estimation task and a single image defocus deblurring. We also demonstrated that the two tasks are beneficial for each other, and the DBView estimation task helped us to reduce the reliance on paired data that require tedious capturing procedure. This framework is also useful for single image defocus deblurring when the dual pixel data is not accessible at inference time. At the end, we got a free byproduct, nice image motion effect called NIMAT effect through synthesizing multiple sub-aperture views from a single input image. Thanks for watching this video. You can scan the QR code here to access the GitHub page for the code and dataset. You can also scan the QR code on the right to check our extension of this work. In this extension, we introduced a modification on the blur synthesis procedure in the smartphone's portrait mode that gives you a nice bokeh photo plus our new NIMAT effect. Thank you.